combination. Hey guys, so we're going to do probability using combinations. It's similar to finding the combinations, but you're just going to take the situation that you're looking for the probability. Like this one, you're looking for the probability that you're dealt a heart flush. So on the top, that's going to be like the situation that you're looking for, the combinations for that situation. It's hard to write with this, so I'm just going to write sit, period, save you my bad handwriting with the mouse pad. And then it's over the total number of possibilities for everything, like for the entire deck of cards. And again, we'll just say total because it's hard to write. Okay, so a flush in a poker game is 5 cards of the same suit. So what would the probability be that it is a heart flush? So what we're going to do is in the denominator, it's going to be the total possibilities for any poker hand. So that's going to be 52. Choose 5 cards. And then in the top, we want the possibility of getting a heart flush. So there's 13 hearts, and we want to choose one of the 13. And 5 of the 13 we want. And if you type these both in, this is 1287, and this is 2,598,960, and that comes out to 0.000495. Okay, so the next one would be the probability that you're dealt any kind of flush. So it's the same thing as last time, but this time there's 4 different suits. So we're going to have 4 possibilities of choosing 5 cards out of the 13 for each suit. So it's basically just 4 times as likely because now we're dealing with 4 suits. Sorry for my handwriting. And this one comes out to or if you realize that you could just multiply this number by 4 and get that number. Okay, the next one, there's a club with 4 men, 5 women, 3 members are getting selected, and what is the probability that it consists of 3 women? So in the numerator, you want to choose 3 women out of 5. So that's the combination that 3 women are getting chosen over the total number of possibilities for all of the candidates. So that would be 9 total people, and choose 3 of them. And that's 0.119. If you plug it in, this is 10, and this is 84. Okay, so for the next one, there's a company this time. Again, it's men and women, 11 men, 9 women. 4 employees are going to be selected from them. Okay, so the first one, this time it's in order. So if we go back to the front, we can only use what we've been using if it's without replacement, if we're choosing more than one, and order does not matter. So for this one, order does matter, so we're not going to be able to use the combinations over combinations. So for this one, we're going to just use the counting principle. So for the first one, if you want to choose 2 men, that would be, you're choosing 11 out of 20. That's the probability of getting a man for the first time. If the second one's going to be a man, then you have 10 left because we chose one of them. And there's 19 total people left. And then the next 2 will be women. There's 9 women to start and 18 people left. And then we chose one of the women, so now there's only 8 left. And 18. There should be 17 actually. And if you multiply that out, it should be 0.068. And then the next one, this one is in any order, so now we can use the combinations. So first we're going to choose 2 men out of 11. And then 2 women out of 9. Over the total possibilities, we're going to choose 4 out of 20 people. And 4. And this turns out to be 55 times 36 over 4,845.